Welcome viewers. In this video we'll see the Kirchhoff's law. There are two laws available, Kirchhoff's current law and Kirchhoff's voltage law. First we'll see the Kirchhoff's current law. It's called KCL, Kirchhoff's current law, KCL. The statement of Kirchhoff's current law is that in a node the sum of entering current is equal to sum of leaving current. If we consider any node, the current entering into the node is equal to current leaving to the node. And in other case, the summation of total current at a junction is equal to 0. Otherwise, the sum of the current entering and current leaving is equal to 0, right? So that can be written as sum of current entering equal to sum of current leaving. So if we consider any node, the total current will be 0. That is, while adding the current entering and while adding the current leaving, adding these both, the total current will be 0. The current entering is treated as positive, current leaving is treated as negative. By adding these two, we'll get the total current as 0, right? We'll see in the diagram so that you are able to understand. Now consider this diagram. There are 4 branches available. So R1, in branch 1, the resistor R1 is available. In branch 2, the resistor R2 available. In branch 3, resistor R3 is available. In branch 4, the resistor R4 is available. So all these branches are connected at this point. This point is called a node or junction point. Right? 4 branches are available. All are connected at this point. It's called a node. We have R1, R2, R3 and R4. 4 resistors are available. The current in the first branch is I1, second branch is I2, third branch is I3, fourth branch is I4. Now see that in branch 1 and branch 3, the currents are going towards the node. Currents are flowing towards the node. That is, current is entering the nodes, I1 and I3. The current flowing through the first branch and second branch, I1 and I3 are flowing towards the node. I see the current flowing through the branch, second branch and fourth branch, I2 and I4. So current or the current is leaving the branch. Current is going away from the branch. See the direction, current direction. I2 and I4 are going away from the node. So I1 and I3 are going towards the node, I2 and I4 going away from the node. So these two, I1 and I3 is taken as a incoming current. I1 and I3 is the incoming current. I2 and I4 is treated as a outgoing current, right? Going away from the node. So according to the Kirchhoff's current law, incoming current, sum of incoming current equal to sum of outgoing current. That is, I1 plus I3 equal to I2 plus I4. The current entering the node, the sum of current entering the node is I1 plus I3. That is equal to sum of current leaving the node, I2 and I4. So this is the statement given by the Kirchhoff's current law. The summation of current entering the node is equal to summation of current leaving the node. Now bring this I2 and I4 from right hand side to left hand side. What will happen? I1 plus I3, this minus I2, this I2 while coming this side minus I2. I4 will coming this side minus I4. That is, I1 plus I3 minus I2 minus I4 equal to 0. That is, the summation of total current at a junction is 0. So these two are incoming current, so it is treated as positive. These two are outgoing current, so it is treated as negative. So while adding all 4 current, it is equal to 0. So that is the statement given by the Kirchhoff's current law, right? So the sum of incoming current is equal to sum of outgoing current. And other statement, the sum of total current in a junction is equal to 0, right? So this is the statement given by the Kirchhoff's current law. Now we'll go to the Kirchhoff's voltage law. Now we'll see Kirchhoff's voltage law, KVL. It is also called as a KVL, Kirchhoff's voltage law. What is the statement given by the Kirchhoff's voltage law? The algebraic sum of voltage around any closed path is 0. If we consider any closed path, the voltage around the closed path is 0. So in the previous case, Kirchhoff's current law, we consider the node, junction point. In Kirchhoff's voltage law, we consider closed path, right? In order to apply KVL, what we need? Closed path is needed. In the closed path, we can apply the KVL. In the closed path, the voltage is 0. In case of Kirchhoff's current law, what we need? Node. At a node, what is the current? What is the incoming current and what is the outgoing current? That is analyzed by Kirchhoff's current law. In voltage law, we are analyzing the voltage in a closed path. In other words, in a closed path, the total EMF is equal to 0. The total EMF. The one EMF may be positive, one EMF may be negative. While adding all the EMF, the total EMF is equal to 0. That is the other. In other words, we can say that total EMF is 0. That is, we can say in a closed path, potential rise is equal to potential drop. Right? Potential rise is equal to potential drop. Otherwise, total potential is equal to 0. Now we'll see this diagram so that you are able to understand. Now consider this closed loop. In KCL, we consider one node, junction point. Here we are consider one closed path. There are three resistors are connected in series, R1, R2 and R3. That is, supply is given. These three resistors are energized by this voltage source, DC voltage source. Right? R1, R2, R3, three resistors are connected in series. That is energized by the voltage V. This I is the current flowing through the closed circuit. Because of three resistors connected in series, the same current I is flowing through all three resistors. The voltage drop across R1 is V1. The voltage drop across R2 is V2. Voltage drop across R3 is V3. Right? So we have three resistors connected in series, energized by the voltage source. The current flowing through the circuit is I, total current is I. The same current is flowing through all three resistors. V1 is the voltage drop across R1, V2 is the voltage drop across R2, V3 is the voltage drop across R3. According to the Kirchhoff's voltage law statement, what is the statement? In a closed path, the voltage around the closed path is 0. Otherwise, potential rise equal to potential drop. What is potential rise? What is potential drop? So this is the supply voltage. It's called a potential rise. The potential is given from this voltage source. This voltage source, what is given to the circuit, is dropped across R1, R2 and R3. This is called potential drop. The applied potential is potential rise. That potential is dropped across three resistors. Depends upon the value of R1, R2, R3, the voltages will be dropped. Right? If more resistor means more voltage will be dropped. So based on R1, R2 value, the voltage will be dropped. So the applied voltage potential rise is equal to potential drop across three resistors. So that is given here. E equal to E is, that is V or E, both are same. The potential applied E or V is equal to V1 plus V2 plus V3. Voltage drop across R1, voltage drop across R2 and voltage drop across R3. So this is a statement given. In a closed loop, potential rise is equal to potential drop. Now bring this V1, V2, V3 from right hand side to left hand side so that it becomes negative. E minus V1 minus V2 minus V3 equal to 0. What is this? In a closed loop, the total potential is equal to 0. So one potential is rise, other potentials are drop. So while adding these two, we'll get 0. So another statement given by the Kirchhoff's voltage law. In a closed path, the total EMF is 0. So how will you find V1? V1 is nothing but voltage across R1. So V equal to IR, the general formula. So V1 equal to I into R1 because I is common. Same current is flowing through the all resistors. So V1 can be written as I into R1. V2 can be written as I into R2. V3 can be written as I into R3. So we can write the final equation E minus I1 IR1 minus IR2 minus IR3 equal to 0. So this is the final equation. The potential across potential in a closed path is equal to 0. This positive indicate potential rise, negatives indicates potential drop. While adding these two, we'll got 0 value. So that is a statement given by the Kirchhoff's voltage law. So in this video we discuss Kirchhoff's current law and voltage law. Kirchhoff's current law, what we need is node. We are analyzing what is the incoming current and outgoing current. Kirchhoff's voltage law is applied in a closed path. We are dealing what is the potential drop in a closed path. What is the potential rise or potential drop in a closed path. Thank you.